Section 3.3, Rules of Differentiation. So a quick note, you can use these derivative rules if simply asked to find the derivative. If the problem asks you to find the derivative using a specific method, you probably will not be using the rules found in the section. So rules of differentiation are super helpful. They kind of feel like you're cheating. But if there's a problem where I ask you to use maybe the limit definition or specifically ask you to find a different way, that's what you should be aware of. But you'll be fairly warned, so don't be too concerned. So I'm going to start off this section by listing all of the theorems, and then we'll do an example. So we'll do a list of examples where we come across and showcase each one of these theorems. To begin, we have the constant rule, and that says the derivative of a constant is 0. So the derivative, if I have f of x equals 1, well, if I want the derivative of that, of any number, is 0. Next, we have the theorem rule. The product rule. If a non-negative integer, then the derivative of x to the n power is n times x raised to the power of n minus 1. So the notation looks funny, but this is probably the best rule we have and the one you'll use the most often. It says, for example, if I have 2x cubed, then in order to take the derivative, what we will do is bring down our exponent so that I now have 2 times 3. And then I'm going to subtract 1 from my exponent. So we have 3 minus 1. So our derivative is actually 6x squared. And with practice, I'm sure you'll be able to do these type of problems in your head. Next, we have the constant multiple rule. If f is differentiable at x and c is a constant, then I can factor out the constant and then apply the derivative. Next, we have the sum rule. If f and g are differentiable at x, then d dx of f of x plus gx equals f prime of x plus g prime of x. Meaning, I can, if I have, you mainly see this in terms, if I have two terms, I can take the derivative of each one separately. And lastly, higher order derivatives. Assuming y equals f of x can be differentiated as often as necessary. The second derivative of it is, so you can write it as f double prime. So that's those two little tick marks. So lets us know it's two derivatives. And you find that by taking the derivative of the derivative. And you can repeat that as many times as you'd like. So for notation, you make quick notes on notation. For your second derivative, you can use either that dash notation, so f double prime of x, or you can also use that d dx notation. So you can use d squared of dx squared. That's something you can also do. Let's do some examples. Find the derivative of each of the following using any method. So for our first one, we see that our function is just a number, it's a constant. So we can use that first rule where it says that the derivative of a constant is 0. Next, B. Okay, this one we can use two theorems at once. I can take the derivative of each one separately, but we know that each constant is a 0. And pi is a number, right? So b prime of x is 0 minus 0. So b prime of x is just 0. For c, we can use the power rule. And that says that I can to find the derivative, bring down my exponent so that I now have 12 times 6, and then subtract my exponent minus 1. All right, 12 times 6 is 72. Now we have x to the 5th power. So our derivative is c prime of x is 72 raised to the x raised to the 5th power. D. Okay, so let's take the derivative of this one. Just like before, I want to think of this as x having an exponent of 1. So I want to bring my exponent down so that I have negative 6 times 1, and then subtract 1 to my exponent, so that I have negative 6, and then I have x to the 0 power. Well, x to the 0 power is just 1. So our derivative is actually just negative 6. Okay, next problem. We can clean it up a bit before we start. We can divide those two numbers so that I have 2x to the 4th power plus 8. Now, for some variety, I can factor out my 2 so that I have x to the 4th power plus 4, and then apply my derivative to each term. So that I have 2 times 4x cubed plus 0, so that my derivative is 2 times 4x cubed, which is just 8x cubed. Or you could have also, to offer some other option, you see, as long as you follow these theorems, you're still doing okay. We could have just done the power rule for each term, so that we have 2 times 4 raised with x raised to the 4 minus 1 plus the derivative of a constant is 0. So that we have 8x cubed plus 0, we still get 8x cubed. Okay, F. For the next problem, whenever you have radicals, it's really helpful if you think of them as a rational exponent. And the square root is an exponent of 1/2. So looking at this, we can definitely use the power rule. So we can go ahead and bring the exponent down and then subtract 1. 1/2 minus 1. Or we can think of it as 1/2 minus 2 over 2, since that is also 1. So that we have 3 with x raised to the 1/2 minus 2 over 2, we get negative half. And while this is our answer, we do not like to have negative exponents, so we need to fix that. So we can write it as 3 with the x to the 1/2 power in the bottom to make it positive. There we go. G. G of x equals 12x cubed plus x squared minus 4x plus 1, and we wish to find the derivative. So let's go ahead and take the derivative of each term. So that we have 12 times 3 times x to the 3 minus 1 plus 2 times x raised to the 2 minus 1 minus 4 times x raised to the 1 minus 1 plus 0. So that we have 36x squared plus 2x to the 1st power minus 4 times x to the 0 power plus 0. So we have 36x squared plus 2x. And x to the 0 power, that's just 1. So we have minus 4. That's g prime of x. Next problem. Let f of x equal 2x cubed minus 15x squared plus 24x. For what values of x does the line tangent to the graph of f have a slope of 6? Okay, well, we need to remember what the derivative does. The derivative provides us with the equation of a tangent line at a point. So if I wish to find my point given the slope, I need to first find the derivative, set that derivative equal to the slope, and then solve for x. Okay, so let's start off by finding the derivative. So our derivative is f prime of x, which is 2 times 3 times x raised to 3 minus 1, minus 15 times 2 with x times raised to the 2 minus 1, plus 24 times 1 with x raised to the 1 minus 1. So that we get 6x squared minus 15x to the first power plus 24, and that x to the 0 power is just 1. And we don't have to write x to the first power. Okay, now I want to have a slope of 6. So that means that this function needs to be set equal to 6. Okay, let's go ahead and solve. Now to solve, I need to set it equal to 0 first. So minus 6, minus 6. Okay, let's go ahead and factor a 6. Actually, I made a mistake, didn't I? Negative 15 times 2, that gives us 30. So that should be 30. Thus, this should be 30. There you go. Okay, now let's continue. Let's factor we can factor out a 6. So we're left with x squared minus 5x minus 3. And we see that we can factor this. There's no such terms that multiply give you 3 and add to give you negative 5. So it's not factorable. If I wish to solve for 0, I need to go ahead and use the quadratic formula. Okay, so just to remind you, I know you know this, but just to give you a quick refresher, your quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. Okay, so we have negative b plus or minus the square root of negative 5 squared minus 4 times my a is 1 and my c is negative 3 all over 2 times your a is 1. So you get 5 plus or minus the square root of 25 plus did I make that? I randomly made yeah, randomly made that a negative, so it's always a plus 3. So that's minus 12 all over 2. So that we have 5 plus or minus the square root of 25 minus 12 is 13 over 2. And we punch that into a calculator and you should get a decimal. So the x values for which you have that those are your zeros, where there is a point with a slope of 6. Very cool. We have answered our question. One more. Find the third derivative of the following function. Okay, so that means I need to compute first. To find the third derivative, I need to first find g prime of x, the first derivative, the second derivative, until I get my third derivative. Okay, so let's go ahead and calculate that first derivative. G prime of t is, well, we have 3, and then we take the exponent of that, so it's 1 minus 1, the derivative. And then we have 2 times 10, and then we have 10 minus 1. So we have 3t to the 0 power plus 20t raised to the 9th power. That's just 1. So we're left with 3 plus 20t to the 9th power. That's our second derivative. Okay, let's take the derivative again. So the derivative of 3 is 0. We bring down the 9. So 9 times 2 is 18. 180t to the 9 minus 1. So that we have g triple prime of t is equal to, well, that 0 is gone, so I have 180t to the 8th power. And there we have it. We have found the third derivative. That's it for section 3.3, rules of differentiation. Thank you.